Welcome to the DIY Honda Garage channel. DTC P0171 indicates that the fuel system in a Honda Civic from 2016 to 2021 is too lean. This means that the air-fuel mixture in the engine is not optimal. There is too much air and not enough fuel. The DTC code is stored in the Powertrain Control Module PCM, which monitors the engine's performance and fuel efficiency. Keeping this code unresolved can lead to poor engine performance, increased emissions, and possible damage over time. Understanding the role of the fuel system is crucial. It involves components like the fuel injectors, fuel pump, and sensors that work together to provide the correct amount of fuel. Each component's functionality is vital in maintaining the engine's balance for efficient combustion. The error DTC P0171 specifically involves a lean condition in the fuel system. Components that can be affected include the fuel injectors, mass airflow, MAF sensor, and oxygen sensors, among others. The MAF sensor measures the amount of air entering the engine, allowing the PCM to add the appropriate amount of fuel. This sensor is typically located in the air intake duct prior to the throttle body. The fuel system also includes the fuel pump, which supplies fuel from the tank to the engine, and fuel injectors that spray the fuel into the combustion chamber. These components must all work in harmony to ensure the engine operates efficiently and produces optimal performance. Several possible causes may lead to the DTC P0171 error code. Aftermarket fuel system components, which may not meet OEM specifications, could disrupt the fuel-air mixture. Additionally, faulty sensors such as the MAF or oxygen sensors can provide incorrect information to the PCM, resulting in improper fuel delivery. Vacuum leaks can also contribute to a lean condition. If air enters the system unmeasured, it can throw off the air-fuel ratio. Wiring issues, damaged hoses, or even software glitches in the PCM may further complicate matters, highlighting the importance of a thorough diagnosis. The symptoms associated with a DTC P0171 may include poor engine performance, as the incorrect fuel mix affects the efficiency of combustion. This often manifests through hesitation during acceleration or a rough idle. Drivers may also notice an increase in fuel consumption as the engine attempts to compensate for the lean condition. The check engine light, MIL, will illuminate on the dashboard, indicating a malfunction that requires attention. Further, emissions levels may rise, contributing to potential failure in emissions testing, which is an important consideration for vehicle owners. Identifying these symptoms early can prevent extensive damage and costly repairs. The first troubleshooting step for DTC P0171 requires performing a problem verification at idle. Start the engine and let it idle in neutral while using the Honda Diagnostics System HDS to check critical parameters. Specifically, monitor the air-fuel feedback AFFB for short-term fuel trim, ST fuel trim. The threshold for acceptable readings is 1.3 or below. If the value is higher than 1.3, this indicates a problem, and you should proceed to step 4. If it's within acceptable limits, continue to step 2. Correctly identifying the feedback readings is crucial, as they indicate how the PCM interprets the fuel mix and necessary adjustments. For the second step, review the onboard snapshot data captured during the first step. Record the relevant parameters, including engine speed, vehicle speed, relative throttle position, TP, and accelerator pedal position, APP, when the AFFB was at its highest. Next, drive the vehicle under the previously determined conditions to assess real-time data. While driving, use the HDS to monitor the AFFB ST fuel trim again. It's important to compare these values against the conditions recorded in the snapshot. Should the values exceed 1.3, you will proceed to the third troubleshooting step. This step is essential for verifying that identified issues are replicable under the same conditions. In troubleshooting step 3, check the mass airflow sensor for debris. Begin by turning the vehicle to the off mode. Then, carefully remove the MAF IAT sensor 1, taking care not to damage it. Inspect the sensor for lint, bugs, or other foreign materials that can obstruct airflow readings. If you find any debris, clean the sensor thoroughly and use a vacuum to remove contaminants from the air cleaner housing. After cleaning, reinstall the sensor and move to step 4. This step is critical as a clean MAF sensor ensures accurate air measurements, which directly affects the air-fuel mixture. The fourth troubleshooting step involves conducting a visual inspection of several critical components. First, turn the vehicle to the off mode and inspect the crankcase breather hose, air cleaner housing, intake air duct, oil cap, and dipstick for any signs of disconnection, cracks, or overall damage. If any components are found to be faulty, they should be repaired or replaced as necessary. This step is vital for eliminating any leaks or disruptions in the air or fuel flow, which could lead to a lean condition. A thorough inspection can often reveal simple fixes that resolve the DTC. Step 5 requires checking the evap canister purge line for any issues. Conduct a visual inspection of non-return valve A, non-return valve B, the evap canister purge valve, and the associated hoses for any signs of damage or disconnection. Any detected faults should be addressed and repaired to ensure the system functions optimally. The evap, evaporative emission control system, prevents fuel vapors from escaping into the atmosphere. A malfunction here could lead to a mixture that is too lean. Correcting issues at this stage can often prevent more complex repairs down the line. In troubleshooting step 6, start the engine and let it idle while gently pinching the brake booster vacuum hose. The purpose of this step is to observe the changes in the AF/FB readings using the HDS. Monitor the parameter values to see if they remain above 1.3. If the values do not increase, the brake booster system is likely functioning correctly. If they do increase, it suggests a potential leak in the brake booster or its hoses. In such a case, a thorough check for leaks will be necessary, and if none are found, the brake booster itself may need to be replaced. For step 7, continue allowing the engine to idle while gently pinching the positive crankcase ventilation (PCV) vacuum hose. This action allows you to monitor the AF/FB parameters with the HDS. If the values exceed the 1.3 threshold, it indicates a potential leak in the PCV system, necessitating a detailed inspection for faults or leakage in the vacuum hoses. The PCV system is critical for preventing pressure buildup in the engine and ensures that emissions are routed back for reburn. Identifying flaws in this system can yield significant improvements in performance. In troubleshooting step 8, start by turning the vehicle to the off mode and disconnecting the intake air duct. This will allow you to conduct a smoke test using a large intake manifold adapter cone. The purpose is to introduce smoke into the system to identify any vacuum leaks in areas such as the manifold itself, gaskets, and all associated hoses. Inspect for any visible signs of smoke escaping during the test. If leaks are identified, they need to be sealed to restore the correct air-fuel mixture. This step is essential as undetected leaks can lead to continuous lean conditions, resulting in the P0171 code. Step 9 involves checking the MAF sensor reading while the engine idles. Ensure that the engine coolant temperature is above 158 degrees Fahrenheit. 70 degrees Celsius, and the transmission is in neutral, with all electrical loads turned off. Then, monitor the engine speed using HDS while maintaining 2,500 RPM for 30 seconds. Observe the MAF sensor output, which should read between 5.3 to 7.4 grams per second, G seconds. If the reading is acceptable, you can proceed to the next step. Any deviations could indicate a faulty MAF sensor or assembly. Accurate readings are crucial for optimal engine performance, as this determines air intake for combustion. In Step 10, verify the fuel pressure when AFFB ST fuel trim is 1.3 or more. This involves checking whether the fuel pressure is within the specified range during operating conditions. If it meets the required levels, the system is functioning correctly, and you can advance to the next step. If the pressure is low or outside of the acceptable range, check that the fuel pump is receiving the correct power supply and ground connection. A malfunctioning fuel supply system can significantly contribute to fuel delivery issues and is a common source of DTC P0171 errors. Ensuring adequate fuel supply is critical to maintain the proper air-fuel mix. Step 11 involves checking the fuel pressure on the high-pressure side. Power on the vehicle, but keep it in the off-lock mode for preparation. Next, clear any existing DTCs with the HDS and start the engine to monitor fuel pressure while holding the engine speed at 3,000 RPM. Use the HDS to access the direct injection II fuel pressure test. If HDS indicates normal pressure, the high-pressure system is functioning correctly. If not, further diagnostic measures should be taken for DTC P0087 and P0088 to determine the underlying issues affecting fuel pressure. This ensures that pressure discrepancies are not contributing to the lean condition indicated by DTC P0171. In Step 12, if the lean condition follows a recent refueling, it may lead to a determination that the issue is fuel-related. Begin by draining the fuel tank and refilling it with known good fuel to eliminate this as a potential source of the problem. After refilling, start the engine and operate the vehicle under the same conditions where the AFFB value was previously high. Use the HDS to analyze AFFB readings while driving. If the AFFB returns to acceptable levels, then the fuel was indeed the issue. If it remains high, proceed to the next troubleshooting step for further analysis. This is a crucial step for isolating the problem specifically to the fuel quality. For troubleshooting Step 13, if previous checks didn't resolve the DTC P0171, the next logical step is to replace the air-fuel AF sensor, Sensor 1, with a known good unit. After replacement, restart the engine and operate the vehicle under the same driving conditions where high AFFB values were noted. Use the HDS again to monitor AFFB readings while driving. If values show improvement and stay within acceptable thresholds, this indicates that the AF sensor was the source of the issue. Should the problem persist, reinstall the original sensor and proceed to the next step to investigate further. The final troubleshooting step involves replacing the fuel injectors with known good injectors. After installation, restart the engine and operate under similar conditions that triggered the original high AFFB reading. Use the HDS to check the AFFB values during this process. If the values remain elevated, the injectors are likely the source of the issue. If the readings are normal, consider substituting a known good powertrain control module, PCM, before concluding the diagnosis. It's essential to replace injectors in sets to maintain balance and efficiency across all cylinders. This step finalizes the troubleshooting process to address the DTC P0171 error effectively. Final repair verification is crucial to ensuring the issue related to DTC P0171 has been resolved successfully. After completing the necessary fixes, recheck the relevant parameters using the HDS to confirm values are now within acceptable limits. Cross-reference with the initial readings for comparison. Once verification shows positive results, proceed to clear DTCs from the system. It's vital not only to fix the immediate problem, but also to confirm that it was resolved effectively to prevent potential recurrence. This final step helps to ensure that the vehicle operates normally without triggering the check engine light again. Preventive maintenance is key to avoiding issues like the DTC P0171 in the future. Regular inspections of the fuel system components, such as injectors and sensors, help catch possible issues before they develop into significant failures. Always use quality OEM parts when replacing any components. Aftermarket parts might not meet specific standards, contributing to future problems. Monitoring engine performance, including fuel economy and response times, can also give early warnings of potential issues. Lastly, keep a routine check on software updates for the PCM, as updates can improve the vehicle's overall performance and diagnostics capabilities. In conclusion, addressing DTC P0171 requires a thorough understanding of its implications on vehicle performance and emissions. By following systematic troubleshooting steps, mechanics can effectively diagnose and resolve the root cause of the lean condition in the fuel system. The process involves a keen focus on individual components and their interaction within the fuel system. Implementing preventive measures can ensure longevity of the vehicle's performance, avoiding unnecessary failures in the future. Lastly, vehicle owners should be aware of symptoms early on, allowing for prompt attention to prevent more significant complications down the road. Please like and subscribe to the channel. See you next time.